Hi, my name is Jonathan. I'll be walking you through a web scraper that I built just for demo purposes. It uses a TMUX session with two PCs. So these are two personal computers that I own and I have them here side by side. It uses high computing techniques to basically just web scrape a website and print all the titles that are on that website. So here we're interested specifically in book titles. So we go to these websites, to this link here, and we get all the titles that are in there and we print them. So to demonstrate this, I'll just go to the website. So you see that the first one is In Her Wake, and you go here to the website, which is page 3 of 50. And the first one is slow states of collapse. So this should be the one matching here, slow states of collapse, because this is page 3 and this is page 2, as you can see the URL links here. So page 3, the first one is slow states of collapse, and the last one is natural history of the US, and it does match this. So here you see natural history of the US. We can go to like page 2 and you can see the titles here as well, the pictures and everything. This is a very friendly website to web scraping. It's actually meant for web scraping. And we display some general statistics about each PC's work and what they did. So here, PC2 completed 2 jobs. And by 2 jobs, I mean 2 different pages. So page 1 and 2, so 2 jobs. It did this in 99 seconds, and this is the throughput. And we can run this as many times as we want since it is in a persistent TMUX session. So if I wanted to run it again, let's say this time I wanted to scrape 4 pages. So now it's going to go ahead and scrape all 4 pages and it'll display the statistics of each one of those pages. This is the work that PC2 did. So here we also have the work that master PC did, which is this PC. And this PC is slightly faster than PC2. So both of them are doing half the work. So we're splitting the work in half and having each one do the work. That can be rearranged in any way. So we can have them help each other, but for demo purposes, it's just we're splitting the work by 2. We can also do like multi-threading on each one of the PCs to speed it up even more. But we're not going to do that here. So here we have all our headers that we need. So Ray essentially is just useful for distributing communication amongst multiple computers or PCs or servers. It basically uses sockets to do this. And we use the OS header mostly for these environment variables. So I didn't want to type my password for Redis here. So I just created an environment variable and I did chmod 600. Here you can see my environment variable. Uh, the environment variable is called from our bash script. So as you can see here, and obviously our bash script uses the Python program, which has access to these variables. So that's the purpose of the OS header up here. And here we have our Redis instance. You can think of Redis as just a database that lives in RAM memory, which is very fast. That's why we're using it, because we don't want to be slowed down. And we use Redis to manage our queues, which we do the work from. Sorry about that. The next one is the request header. So here we just use it to make HTTP requests. And here we use Beautiful Soup to create a DOM tree, which we will get all of our HTML H3 headers from, which is where we get our titles from. Here we use time for statistic purposes, and we use dictionary and list, and just logging for logging the errors or the info. Here we define how we want our logging to behave. So we essentially dictate the minimum level of messages that we can display. So there's different I guess you can think of them as levels of logging. So you don't have to display all errors or all logs, um, which ideally there shouldn't be any, but you can control that. And here we just format in the way we want those errors to be printed. So it's pretty simple. And here we basically assign those environment variables to actual uh, Redis password and port, and the ports of the Redis host as well, and the array address. And here we start our first definition in Python. So that's going to be enqueue URLs. For this one, all we do is enqueue the URLs and split the work amongst our worker and our master PC. Like I said before, this PC is a master PC. Okay, so here we split the work. I think it might be helpful if I show you all a diagram. So I did pull up my a website here that I have running locally using Cloudflare. Um, let me see if I can. Uh, it was, I believe it's that one. No, I misspelled it. Okay, here it is. It's solar.grabjonathan.org. Okay, looks like I just misspelled it. So this is just a resume website. So here I have a diagram explaining this program, and you should be able to see this diagram here, which, like I said, it has the Redis server. So in that function, we're starting this Redis server, which basically gets enqueued. So right now we're following this line with the arrow that goes from our Python controller, which is the program I'm showing you, to the Redis server. Okay, so the Redis server, there's two queues in there. One belongs to master and one belongs to the worker. So master is here and worker is here on the right hand side. Hopefully that makes sense to you. And here we start our Redis instance, like I said, and we declare our two queues. We declare the website, which we're going to be scraping from. And here we say the range in which we scrape from. So if you remember earlier when we ran our program, our program asks you how many do you want to scrape, right? So this is how many we're going to scrape. This is what manages that. And here we just split the work amongst the two queues and we just say, okay, we're good. We successfully enqueued. So you'll see that here. So successfully enqueued 3 URLs. Hopefully you saw that. Successfully enqueued 3 URLs. And okay, one moment. So that's basically it for the first function. It's pretty simple. You just enqueue, start Redis, and split the work. Next, we have our main function. So this is what does most of the work, and it does call a helper function, which is also very important. So monitor node performance, gets the statistics, and calls and does the work. So it calls process URL, which processes each URL and gets the data from the dump tree. I'll explain what that is here in a moment. So here we have Ray remote, which essentially is our two Ray workers. So we have master and we have the web scraper PC2. So master PC basically runs this Python script and the main bash script that you see here. So if you're not familiar with bash scripting, I do recommend that you learn it before I walk you through this, because it'll sound pretty cryptic if you're not familiar with this. So this Ray instance only calls one function, which is monitor node performance. So it calls nothing else, just that one function. Okay, so this function right here, which is monitor node performance. And you can think of it like we're nesting our functions, because monitor node performance calls process URL, which is another function here, right under it. I'll explain what that is in a moment. So here we did just declare basic variables for logging purposes. You don't have to be too concerned about those to understand how this program works. Here we start our Redis instance. This is very important. So we essentially connect to Redis and make sure that we're connected. And we get a URL from our Redis instance. So QName, for example, going back to our original function just to show you what QName would be. So QName would be either PC2Q or Messer Q. So that's what this variable here would be. And the node label is just like, for example, Messer or PC2. And we get the thing from, we get the object from Q name, and we take it out of the queue and we pop it out of there from the left. So, from the rightmost element. And if there's nothing in there, we just exit. And we start our titles object, and we're gonna run this while loop until there's no more titles to scrape from the website, or no more URLs, I should say, which each have a lot of titles. So if titles do not start with an error, then we can process them. Because if there's no titles, which I tried before on a page that has no titles, it'll start with error. So that's why I did this line here. So if it doesn't start with errors, then we can go ahead and look for our titles. And once we find those titles, we're going to just add them to this scrape data here. And we increase our completed tasks. This will only increment when we have completed the adding all the titles there. So if there's errors, then we'll just append those errors and display them. Ideally, there should be no errors printed. Like as you can see here, there's no errors that are printed when we call these. So there's no errors as of right now. And like I said, the heavy lifting is done by this function, which is a process URL. And we'll just go over that here, what that does. Very important. This is what actually does the actual scraping. So this is more, the Redis and the Ray is more for distributed computing or high performance computing, if you want to call it. Basically the same ideas. This right here is what does the scraping, and all the other things that are layered on it are just for high distributed computing. So here, the actual scraping, all we do is we go ahead and get our URL. We go ahead and create a DOM object, which basically creates a tree of our HTML. And once we have that, we go ahead and parse through it. We look through that tree for H3 headers, and we look for all the titles that are in there. And we will save those titles and return those titles. If there's any errors, then we'll log those. So here we use our request header to create an HTTP request, and then we make sure that there's a valid request, and then we create our DOM tree, and then we look through that DOM tree and get the data that we want. That's basically it. Pretty straightforward. And then we go on here. I already explained these two. Remote functions, and here we just distribute the tasks, and we print the results. So these I don't think you need to understand the logic of the program. So here we're just basically formatting the printing. Pretty straightforward. And here we just go ahead and distribute the task. Here we can change this function and change the way in which the actual websites are being scraped, and that can speed up your program significantly. But here, just for demo purposes, I have it as just split them by two, but you can definitely optimize this one in whichever way you want. But I like to have it like this just because it looks nice. Specifically, this looks nice. It shows you how many web pages each one did specifically. Otherwise, you'd have many statistics for each instance of the cause for each task. So, which can speed up your program, like I said, but it won't look as nice. It will still have all the data, but it'll just be very long. Uh, I hope that makes sense to you. And here we just get the total pages, and we go ahead and make sure that the total pages we're going to scrape are equal to or less than 50. If they're not, then we probably won't be able to scrape them because there's only 50 pages in the website. Go back to the website. There's 50 pages. That's a max on this website. So there's many different sections, and each of them has their own max. Okay, but here we're just focused on this one. So here we're just calling those functions that I explained, and that's basically it for our array program. So I just went over the core logic, not the specific printing, which is very basic. Here is our bash script. So before I was typing in the data manually, but I decided to create that environment file that I explained in the beginning of the video. And here we just start our bash script. So this starts our TMUX session and uses these variables to start sessions of Redis and start a session of Ray. Essentially, I'll show you a demo on how that looks in the terminal. Um, uh, Here, I can close this one and start a new one. I will need to start my script on my second PC here. So just give me a second. All right. We're going to go ahead and run our script again. Okay. Our script is master, setup master. I misspelled that. Okay. We can start running that. Says, do you want to run the TMUX session now? We're going to go ahead and click yes. Do you want to open the session now? So yeah, we can go ahead and run the program, and we have the program running. It's expecting you to type in how many pages you want to scrape, and you run it, and it works. Without the TMUX session, you would have to run the script every single time, which can be tedious. So that's why I use the TMUX session mostly. And for the TMUX session to be joined by the other program, I am using UWF as well to allow that. So I know this is very technical. If it doesn't make sense, Google would be greatly helpful if you truly want to understand the program. And I guess we can just go over the actual diagram here that I drew out. So here we have the master node and the worker node. So here, what you just saw me run a couple of seconds ago was the TMUX session using the Ray master where my mouse is at. You can see that it runs the bash script, starts the environment, and runs the Python script as well. Supports the environment headers, runs the Ray instance, and Redis starts both of them. And this one joins those instances and essentially launches the worker with the specific resource tags. So if you're not familiar with a resource tag, okay, sorry, that's the wrong program. Okay, so the resource tags would be these, for example. These are resource tags, and um, these are resource tags. So these resource tags belong to this super scraper PC2, and this one belongs to the master scraper. So each one has a resource tag. That's how we split them apart and differentiate them. And here, like I mentioned earlier, you go ahead and get the data from the website and you bring it here to the controller and where it's converted into a DOM tree and scraped. And once you have the scraped data from the objects, then you can go ahead and just fetch it back into the Python controller. It's taken to the array, which does the work and dequeues the work into it and brings that back into the controller. And that's basically it. It's not a very complicated program. It's just a web scraper. It does, however, go above just a web scraper and to uses a web scraper to distribute the workload amongst two computers, which is why I built this, just to get familiar. So this is my first attempt at distributing work amongst two different PCs. I've done multi-threading in the past and different ways to do that. I also have other programs on that I should be uploading soon, but I just haven't had time for that. But as of right now, this is the explanation for this Ray controller, which runs a web scraper using distributed computing or high performance computing. You can also go to my website and see a more in detail explanation on how that works. I explain it in as much detail as I can on what everything does here in these couple paragraphs. And that would be it. Again, thank you.